Hi my students, today we are going to complete the last lesson, which is sound waves. By the end of this lesson, you will know how to calculate speed of sound, factors affecting on the speed of sound, characteristics of sound waves, and meaning of ultrasonic. Speed of sound. Just like all longitudinal wave, sound waves possess a velocity, frequency, wavelength, phase, period, and amplitude. We will calculate speed of sound by two ways. First way to calculate the speed of sound by using this formula, V equal D over T. V is the speed of sound, D distance traveled by the sound, and T is the time taken. This formula can be used to calculate speed of sound, or we can use wave equation, which is V equal lambda times F. V is the speed, lambda is the wavelength of the sound, F is the frequency of the sound. The unit of speed in SI unit is meter per second. So we have two ways to calculate the speed of sound, by using D over T or by using wave equation. This depends on the givens in the exam. After that, factors affecting the speed of sound. We have four factors affecting the speed of sound. First one, type of medium. Travels better through liquids and solids, and gas cannot travel through a vacuum. So speed or sound need medium to travel through it, but it travels faster in solids, after that in liquids, and the lowest speed in gas. Second factor is the temperature of medium. Sound travel faster at higher temperature. Third factor is the density. Sound moves well through dense material. Fourth factor is elasticity. Sound waves move fast through elastic materials. So we have four factors affecting the speed of sounds. We know before that voice of men differ from voice of women. Also, voice of children differ from voice of teenagers. This is because differences in shape of the air cavities in the throat, mouth, and nasal regions. Also, this differ resulted from change of pitch and loudness of the voice. Firstly, frequency and pitch. One main difference between man's voice and woman's voice is the pitch. Men usually have voice of lower pitch than women. Children usually have voice of higher pitch than adult. A high-pitched sound has higher frequency, as more waves pass through each point in 1 second. So, high-pitched sound has higher frequency. From the figures, we have two diagrams. First one with low frequency, so low pitch. Second one, high frequency, so higher pitch. Pitch depends on frequency, directly proportional with frequency. Low frequency mean low pitch. Higher frequency mean higher pitch. And frequency defined as number of waves passed in 1 second. Second characteristic of sound is loudness. Loudness depends on the amplitude. And amplitude, if you remember, defined as the height of crest or trough of the sound wave measured from the center line. Loud sound mean it has high amplitude. Soft sound mean it has a small amplitude. So directly proportional between loudness and amplitude. From these diagrams, first one, soft sound because its amplitude is small. Second diagram refers to loud sound because its amplitude is high. So frequency is directly proportional to pitches and amplitude directly proportional to loudness. Higher frequency mean higher pitches, lower frequencies mean lower pitches. And higher amplitude refer to loud sound, lower amplitude refer to soft sound. Range of audible frequencies. For a healthy human ear, frequency ranging between 20 Hz to 20,000 Hz. Sounds that a human ear can hear is an example. So, our ear can hear only frequencies between 20 Hz to 20,000 Hz. Frequencies below 20 Hz cannot hear by our ear. Also, frequencies more than 20 kHz also cannot heard by our ear. Infrasonics mean frequency below 20 Hz. So, there are a range for audible frequencies. Ultrasound, also it is known as ultrasonic. Ultrasound is sound waves with frequencies higher than the upper audible limit of a human hearing. We know the upper limit is 20 kHz, so sounds upper this limit called ultrasound. Ultrasound is not different from normal audible sound in its physical properties. Ultrasound has same properties of normal sound, except that humans cannot hear it. So ultrasound cannot heard by human. This limit is varies from person to person and is approximately 20 kHz. In healthy young adult, ultrasound devices operate with frequencies from 20 kHz up to several gigahertz. So ultrasound has same properties of normal sound, except that humans cannot hear it. Now we are going to solve some questions related to speed of sound. First question: a sound source produces 10 vibrations in 2 seconds. Calculate the wavelength of the source if speed of sound in air equal 340 meters per second. To calculate wavelength, we will use wave equation because the givens are speed and a time, number of waves. From time and number of waves we can calculate the frequency. After that we will calculate wavelength. So frequency calculated by number of vibrations divided by time. So frequency equal 10 divided by 2 equal 5 Hz. Now we will use wave equation to calculate wavelength. V equal lambda times V equal 340, lambda unknown, F equal 5. To get lambda we will divide it by 5. So lambda equal 68 meter. Second question: which of the following diagrams has the louder sound? We know before that loudness depends on amplitude. The higher amplitude refers to loudness. Lower amplitude refers to soft sound. So we will choose between diagrams depending on the amplitude. First diagram has amplitude equal 8. Second one amplitude equal 3. Third one its amplitude equal 6. Last one its amplitude equal 4. So which one has the louder sound? Louder sound mean higher amplitude. So diagram A refer to louder sound because its amplitude is the highest one. Now we ended our lesson. Try to solve the questions that uploaded on Moodle.